Hello everybody, thank you for joining and welcome to our global SMT packaging show live from Productronica. Today we are going to talk about design for manufacturing and manufacturing driven design. And I have three very interesting guests and a specialist on these topics with me on the board. First of all, to my far left, it's Elias Vögel. He is the founder and CEO of Pick to Place, which is a highly automated, low-cost EMS company within Europe, trying to combat also prices from Far East Asia. And Multivertive, which is a software company and consulting company specialized in digitalization and process optimization. To his right, it's Andreas Walter. He's founder and CEO of Electronic Academy. He's very experienced, like more than 30 years of experience in the industry. He was managing director of a couple of companies and is nowadays helping managing directors again to improve their processes, and is very hands-on and far away from just some nice shiny presentations to actually do actionable improvements on the shop floor also. And to my right, to my left, sorry, to my left, it's Axel Lindelhoff from Koyang. He's also very experienced for several years in the industry, has been working on SMT and printing for several years, also in sales, and is now for 15 years roundabout with Koyang and helping improving the inspection side of the process. So all of you, we have very specific and very special view on design for manufacturing, and each of you have your own perspective on how important design for manufacturing is for competitiveness and what we can do as an industry and how we can help the community to improve our competitiveness with other companies and as Europe, let's say, to put it a little more wider. So maybe Andreas, if you want to start, you're probably have realized projects from scratch to series application. Can you tell us a little bit, maybe you have one or two examples of projects with and without a DFM and what that means to cost, to manufacturing and to series quality?
No, for sure. So within my projects, from low volume to high volume and from small size companies to global players, I see even in the whiteness that DFM is not DFM. So therefore, for me, DFM is like playing with Lego bricks. If you have a good instruction, a clear path to follow, then your result is brilliant. If you have to improve or to go sideways, or you don't have a clear instruction how to perform, to build the Lego bricks, it's similar like to build a product. So if you don't have in your design a clear path, a clear checklist, what to follow, then you can't expect a good result. So for example, what I saw as a good example in the past, if the design engineer and the development guys has experience out of the shop floor, they really understand the processes and the boundaries also of the processes, then their designs are more robust, easier to build, and the failure rate is much lower. As a bad example, for example, if a design engineer is using a standard library and something changed, or even standard library cannot cover all 3 IPC classes, for example. So they are in a middle way, let's call it class 2. But if you would like to build a class 3 product with a standard library, this will not match.
Can you give us an idea of how far away in terms of cost is a project with and without DFM, good DFM, or let's say suitable DFM to the application? Because in the end, DFM probably also costs, or it's an effort that has to be paid ultimately by the customer, and it has to pay off. So maybe in your direction, Elias, can you tell us, you probably see as a high mix, low cost EMS company, which is your objective. Can you give us an idea of how much is the difference in effort for you and ultimately the cost for you between good and bad manufacturable PCBs and circuit boards?
Yeah, the difference can be really huge. In fact, it really depends on the single production steps that are in the whole process. But we can talk about, for some production steps, we can talk about twice the time we need, or even 3 times or 4 times the time is needed for completing the production steps. And we are talking a lot about how can we get production back from Asia, and we are specialized in the prototyping segment, so we are only doing quantities of 1 to 10 usually, and there the cost pressure is even is very high, in fact. And so we have the challenge: how can we price prototypes in a fair manner? Because we want to give a fair and a very good and affordable price to good designs, and we want to calculate the additional time we need for bad designs for those customers that do not do good designs or don't have the insights and experience in this field. And so to provide affordable manufacturing, it's very important to also integrate that manufacturability into the pricing.
Very interesting. And you, from your machine, like you are probably realizing a lot of projects also from a machine perspective and from a machine supplier perspective. So certainly the request of your customers can vary a lot. Like how do you deal with that? I mean, it's primarily inspection.
Yeah.
So is there a big difference between well inspectionable PCBAs and hard ones?
Yes, yes. What many people don't know, I'm also responsible at Koyang for the production of our SPI AOI benchmark board. And in the benchmark board, we do all the failures.
Very good.
But we produce the failures. And
Intentionally.
Intentionally, yeah. And that means we know exactly what we are today talking about. And to give you a price idea, so if you can do a product with manufacturable design, with a standard stencil, we are talking about a stainless steel laser cut stencil, let's say about 100 euros. The stencil we use for our benchmark board, because we have 4 steps inside, we have extreme layouts where we have shadowing components and this kind of stuff, which make inspection really a pain in the ... So we pay for stencil for this design 1,000 euro.
So it's
because
a factor of 10.
Yeah, it's a special made stencil with 4 steps, with special coating to get a better paste release, that we can combine 001, 005 components with large components and everything in one process. And it's an extreme effort. And there we come to the design failures already. Mm-hmm. What we see in real production is that the component mixture is too extreme, that you cannot do it, or the component positions causing shadowing, so that some inspection technologies cannot be used anymore.
Yeah. So the component should be out of glass. So let's assume just one question, or one general question, maybe also in your direction. Let's assume the designer, he doesn't do that because he wants to make it bad, but there's certainly also cases where it's necessary to do it to comply with the requirements of the application. So then the question arises, what are the limitations of our processing machines, which is thermal limitations, which is geometry limitations, and those and so on. Maybe this could be something for you. How do you see that as you see all the way from design to manufacturing?
So especially in miniaturization, the space is a limitation, and here you have some guidelines you would like to follow, but you have to also to place all the components on a small piece of PCB, and therefore it's sometimes necessary that you do not follow the standard rules. And or if you have a design and design is not working and a redesign is mandatory. For example, I had this in an automotive product where a SMD component was planned for a sensor, and this SMD component did not fit to the environmental requirements. Therefore, a P2H component have to be assembled with a selective solder process, but the space around was not there. So we had to move and redesign the whole PCB to generate this free place for the solder nozzle that you can solder this PTH component.
Right. And Elias, how do you think about these aspects? Like, how would you decide what criteria do you apply to be able to price your customers, as you said, in a fair way? And I mean, it's really hard to. What's your criteria to do that?
Basically, we just to look into our production and see what are the cost and time drivers. And I would say there are mainly two components to that. And the first one is THT soldering, which is for sure a manual process in those quantities we are talking in our section. And the second one is rework that is caused by bad DFM, for example, designs that cause thumbstones and so on. And when we talk about THT, it's possible that a solder joint takes 5 times the duration to solder it than a solder joint that is well designed. And if you have 20% of designs that are designed in a bad manner, then it doubles the cost in total for all the customers. And so the solderability for THT solder joints can be one of those aspects that we can put into the pricing equation.
Sure. And how would you recommend, or what would you recommend to designers? Or like, it's obviously this limitations that we have from our processes. How would you think could we either document that? Because state of the art is the designer does something, and then possibly either the machine supplier blames him because he did it wrong, or not good enough, or not manufacturable above. Like, we somehow need to meet in the middle, because obviously physics can't be tricked. On the other hand, we do need have the applications low space as less space on the PCB, like miniaturization is one thing. The other thing is power density increases with miniaturization. That also holds true for through-hole soldering. Integration of logic and power on one board. So there are a lot of things that come into play when we have so widely such a wide range of applications and requirements from all the domains, which is machine, which is application, which is manufacturing, which is PCB design, and so on. How would you wish it would be done?
Maybe I can answer. As a benchmark board producer, I have an EMS who's doing this for me. And I can only recommend look for the right partner who gives you, who you can talk to, and who turns your wishes into reality, into production reality. Because I'm not the expert for his placement machine, I'm not the expert for his selective soldering, but I have a requirement I must fulfill. And as soon the dialogue starts, before you have the ready design of the PCB, you are already on the winner side. If you have a PCB designed and ordered and it pops up on your EMS factory and he looks, see at the first look, it's not, we cannot make it, then a lot of cost, time, effort, resources are already gone. So the first step for me, for DFM, is to look for the right partner who can do this for you, and to start the communication with this partner, what is manageable and what not.
Maybe towards Andreas, let's suppose we have, like, there's basically two solutions. You have either an OEM company which also does manufacturing in-house. So I would assume this problem, which you just cited, would be solved. But in fact, it is not. They have the same issues because of the size of their organization. So it's probably the sense for communication and a good standard communication basis that helps us, because in the end it doesn't matter. It's two domains. Let's talk about domains rather than different companies. And Elias, you also just mentioned this on LinkedIn, like this vertical integration. As companies increase and grow, it's hard to communicate between, it's getting harder to communicate, and the more integrated the systems are, the more difficult that will become. How can we solve that problem and get better, even possibly better than our competitors? Like, what's your ideas, thought on that?
So if I would have a big wish, that would be that we have a common document as an industry standard document for DFM. But in my personal view, that's not 100% given. Each company follows its own rules, some better, some worse. And if we have a look to the IPC guidelines, you have a lot of different documents where this information is mentioned. For example, how to design a PTH connection with thermal mass. So the recommendation is use thermal reliefs. But not all designers know that, and even if they know that, sometimes they forget to design it in because it's not in the library, and they choose the data out of the library. So therefore, my wish would be to work together on a kind of standard document for design for manufacturing from beginning to the end of the whole production flow. That would be a huge benefit for the whole industry.
All right, let me state one thing against this. We just said that every application has its own requirements. Yeah. Now, if we had, let's talk about methodology. The methodology to have one set of rules that describes good or bad manufacturability would be great. The question for me is whether that can be applied, and whether the applications that we need to fulfill, the requirements that we need to fulfill, can be fulfilled. And I would argue that we would probably reduce our solution space, trying to standardize, which is great for cost but bad for individualization and new applications. And I would state that, on the other hand, rather than suggesting a rule set, having a methodology, an evaluation methodology that is applied by everybody. So that could be simulation, that could be, and now this has to be aligned with the process. So certain processes certainly work very well with design rules. Others, and this is what you just mentioned with through-hole soldering, it's very, very sensitive to design. There do exist some design rules, but they may miss the point. They don't consider physics of the process. So this comes with, we have limitations of our rules, we have limitations of processes, physics processes. And I would state that a set of rule is too strict, and we should maybe think about a simulation or somehow modeling approach, a digital twin of the model of the processes to check, and so everybody can check with his parameters possibly. Maybe, do you have an idea on that?
Yeah, that's exactly what I think of how the future should look like, because I have the feeling that the manufacturing side and the development side is more divided than ever, and the trend is enforcing that in the future. And so we need digital solutions to give this feedback from the manufacturing back to the developers and provide them with knowledge why something is a problem, for example, why we need thermal reliefs, for example. And I think there's a huge chance for tool simulation and so on to provide this information with just one click, and also parameterize this with the different specifications you have in your own manufacturing shop floor. So a designer can upload the design into the tool and get a list of what are the cost drivers in manufacturing and what he or she can improve to make life easier for the people at the shop floor.
Did you want to comment on that?
Artificial intelligence is maybe a way or collecting all the data, but the biggest problem is, from the discussion I had about that point, the fear of the companies to give out internal data for a common tool which the competitor also can use, and also give out knowledge, and also give out or stand to the failures that they did in the past. So no one likes to talk about his failures. So we have this issue, we have this failure, and therefore for developing such a powerful tool you need good real process data. And here I see the problem that a lot of companies have the fear to give that data out.
I think the longer we fear our neighbors here in Europe, the harder it will be to compete against China or other Asian countries in the future. And I really think we have to change this mindset in the industry. And I also have the feeling it gets better slowly, but it does. Also with younger generations come to the leadership of the companies. That there is a mindset of we can all win if we work together, if we share data and knowledge to compete against very well vertical integrated companies in Far Asia.
I see here a chance for the equipment supplier, because the equipment supplier can provide the tools because he knows his process. And for example, in our case, we control the printing process, the placement process, and we do this by having process models for this process for our propose. but I can imagine that selective wave supplier can provide a model for his process as well, so that you can simulate your design with the tool of the equipment supplier, and then we haven't got this problem of the data leakage. But it's a little bit more effort because you have then to run your design to different tools of the equipment suppliers. And maybe another important way is, even if you have these tools, you must handle these tools and you must understand the tools. Not the way how an AI network is created and how it works, but the process behind the AI model. You must still understand the process.
Right.
And for this, I think, in the last companies I started, I had every time an onboarding process. And in the first company I started, an onboarding from the goods entry to the shipment. So exactly what every division, every department was doing. And I think this is the key. If the designer understands the production, if they really spend a few weeks, a month in production during their onboarding, in each process a little bit, so that they understand what are the bottlenecks, what are the pitfalls in these processes, they are much more sensitized and ask in advance the process expert, can I do this way, or is there any recommendation or alternative?
Well, I like that idea of having like a model for every single machine. But let me roll back that a little bit towards what you just said, Elias. It's about feedback. And what I fear is that we do not even have a single standard of how we provide feedback. And PDF or PowerPoint is not the right way. It's not the way how a structured software can read this unstructured data unless you put it into large language models, which still... So I think that is not the right way. So before thinking about AI and let's say almighty digital twin, we would probably have to think about how can we provide feedback in a structured way across suppliers and across vendors.
That's my turn.
Okay.
We have a gold mine in each production, a data
sure.
a data mine, and today in many inspection tasks, 3D data, measurement data is saved for that the end customer on demand can see the data, but the data is not utilized, but the data is there, and we can describe any process with the inspection data of different inspection states, and this can be utilized, and this can be shared with the equipment vendor, and then we can create models out of this data. This takes time, and this takes a lot of effort, but if the standard model is there, we can update this model with running real-time process data. We can make the model better and better and better.
And then obviously you could also use that model for, let's say, a simulation, although it's maybe AI or whatever tool. I mean, AI is just a tool as well. We can use this to check manufacturability based on, let's say, digital methodologies, digital models, rather than trying to build physical prototypes. All right. I would suggest we make a quick last round. Like everybody, if you could state what you feel the designers, what you would like to, from your production experience, what would you like most that your designers know about what they should improve? Like one thing.
Get an idea of how manufacturing works at the shop floor. That would be my number one suggestion.
Then I need a different one. One important thing is to use the feedback out of the shop floor from first article reports, for example, from prototypes, and really put this information as a lesson learned for further designs.
do a design review with a process expert. So the idea is there, your effort is there, but before you press the order button for the PCB manufacturer, do the design review with your experts.
Thank you very much. Thank you very much. I hope all of you attendees know a little bit more about design for manufacturing and manufacturing-driven design. So going away from rules, more towards digital twins of processes. And I hope you could take with you some very important points how to improve your next designs and manufacturing processes. Thank you very much for your time. And if you want to know a little bit more about design for testing and reliability, check in on Friday. Thank you very much and stay tuned.